Okay, so here we have a bag, right? That has marbles in it. We have 2 gold marbles in the bag, okay? There are 10 silver marbles, and there's 25 black marbles as well, okay? Now, let's say that someone offers to play the game, okay? So, again, I'm reading the problem again, right? And you're picking a marble at random from the bag. I already said what happens depending on the marble. It's already written there, actually. What happens depending on the marble you choose, okay? Now, I was going to say, okay. So we want to know the expected value, okay? So what we have to do is consider each outcome, right? And then, calculate the probability, what happens, and the probability. So if we choose a gold marble, we reach into the bag. Again, the marbles, you cannot tell the difference, unless you actually look at them. They're indistinguishable except for their color. Okay? So in other words, the outcomes are equal. Yeah, each marble is, I guess, equally. Let me not say that. It's going to cause more confusion. Sorry, I'm going off tangent. But anyway, sorry. So for gold marble, right? If you choose that, we get $3, right? We win $3. Right? We win $3. And how likely is that? Well, there's 2 gold marbles in the bag, right? And there's 37 marbles altogether. So the probability of this happening, choosing a gold marble, is 2 out of 37. So if we multiply, right, if this happens, we win $3. So we're multiplying 3 by 2 over 37, right, the amount. We get 6 over 37. So that's what's happening here. Again, expected value, we're using it with experiments where you can win or lose money. Here we can win 3. If we choose a silver marble instead of gold, we win $2, as you can see. Okay, we win $2. Okay, now, so now how likely is that? What's the probability of that happening? Well, there are 10 silver marbles in the bag. There's 37 altogether, so 10 out of 37. Next, we multiply, right? Multiply the products, as you can see. We get 20 out of 37. Remember, when you multiply a number with a fraction, you only multiply the numerators. That's all you do. Okay, that's all you do. Okay. Now, for a black marble, if you choose that, you lose $1. That's why we have a negative here, because you're losing money. Okay? Now, there are 25 of those, so the probability of this is 25 out of 37. So if we multiply, we get this. Now, if we were to add up these numbers, right? These products, that is, what we end up getting, remember, when you add fractions, you're only adding the numerators if the denominators are the same, and they are here. And why is that 27? That should be a 37. So here, let me figure it out. That should be a 37. I don't know why I had 27. I know. So from here, we end up with 6 plus 20 minus 25 over 37, right? And so we end up with 1 over 37 as our expected value. The fact that it's positive, that tells us we theoretically should play this game. we should expect to win, in other words. Sometimes we may not, but this is the kind of game we should play. This is what should happen. Let me just do this. Okay, so I hope this makes sense. Let me just do this poll thing or whatever you call it. I'd like to know if this makes sense. The idea isn't terrible. So that's really just, again, for multiplying for each outcome how much you win or lose by the probability and just adding up. That's really all it is. So. Looks like people are getting it. So because of that, I think what I'm going to do is keep going then. All right. Does anyone have any questions? Okay. Well, let me keep going then. So now we're going to make this one a little more interesting. So now we're going to say, well, what happens then instead of losing $1? What if we lose $2 instead? I know I probably should have replaced the excuse me, restate the marble. Restate the problem here. But now we're going to ask, well, what happens if you choose a black marble and instead you lose $2, not just $1? Well, the other two are the same, the other outcomes. So everything else is the same. So, if you choose a gold marble, you still win, okay? If you choose a silver marble, right, you still win. I don't know why I had 27 down there, but whatever. The only difference now is that if you choose a black marble, right, you're not going to lose just $1. You're going to lose $2. So that product is going to be different. The other products are the same. Okay? So here we have negative 50 over 37. So just like before, what we're going to do is, that should be 50. Oh my gosh. Sorry about those mistakes. Now, wrong button. There we go. So now what happens is, goodness. I think I pressed the wrong button. It brought me back to the beginning. Here we go. Okay, so now, well, here's our expected value, right? 6 plus 20 minus 50. Again, it's the same procedure. We multiply, we add up the products, and we get negative 24 over 37. So now it's negative. So because of that, we should not play this game. I mean, sometimes we might win, but in the long run, we're going to lose. So I guess if you do play it, once you win, maybe walk away. Oh, that doesn't make sense. So I would just not play it. So, all right, so that's this example. There we go. Let's do another one now, okay? So here's another game we're going to play, so to say. These are all these games. So we're rolling a standard 6-sided die once. At standard, again, that means that every outcome is equally likely. Each of the 6 numbers you can get. If we roll 6, you get $3. Okay. If we roll a 5, you get nothing. If you roll less than a 5, so if you roll a 1, 2, 3, or 4, you'll lose $1. Okay, but what is the expected value of this game? Well, let's see. Notice the outcomes here, right? If we roll a 6, we get $3. So really earning $3, I guess, would be an outcome. How likely can this occur? Well, each number is equally likely, so that's probability 1 over 6. So the product here would be, 3 out of 6. 3 times 1 over 6, which is 3 out of 6. If we were to roll a 5, though, instead, okay, we would then get 0. We earn nothing, right? So we get no money. That has probability 1 over 6. 5, again, this is likely a 6. Multiply, get the product, you get 0. Okay. If we were to roll a 1, though, right, we lose $1. That's 1 over 6, right? It has probability 1 over 6, so we have -1 times that. If we roll a 2, same thing. Roll a 3, same thing. Roll a 4, same thing. Because these numbers are equally likely, and each time we're losing $1. Okay? I mean, I'm sure there's a better way to calculate this, but again, when I was writing up the notes, I wanted to show all the details so everyone understands. But anyway, when we add up these products, as you can see, we get -1 over 6. So in other words, this kind of game is not the kind of game you would want to play. Again, that's because in the long run, we're going to lose money. We're going to lose money. We're going to lose in the long run. So this is not the kind of game we should play. As you can see, it's not fair for us. It's not fair at all, actually, because to be fair, the expected value would have to be 0. Okay. I think that might be, yep, that's it for this. Okay. So